In this video, I'm going to talk about how to solve right triangle word problems. The goal is to use the primary trigonometric ratios to solve problems that involve right triangle models. Okay, let's look at the first questions. Jackie's work for an oil company. She needs to drill a well to oil deposit. The deposit lies 2,300 meters below the bottom lake, which is 150 meters deep. A well must be drilled at an angle from site on land. The site is 100 meters away from the point directly above the deposit. At what angle to the Earth's surface should Jackie drill the well? Determine the angle at which the well should be drilled. So I draw a diagram here. So this is the oil deposit, and this is top of the lake. This is the drill site, and this is the bottom lake. So the lake is deep 150 meters from top of lake to the bottom lake, and 2,300 meters. That is deposit lie below the bottom. Right, this is below the bottom, and this is right triangles. So this is seat. This seat is angle of depressions, also called angle of declination. So the angles between the horizontal line, this horizontal line, and this another line is a line of sight when looking down the object. So this angle between the horizontal line and this line we call the angle of depression. So this is the angle of depression. So it means we determine this angle, right? So let's look at this right triangle. This opposite side to the angle seat. This is adjacent side, 1,000 meters. Okay. So because the D, so this equals this opposite side should 150 meters plus 2,300 meters equals 2,450 meters. So this is D, right? Okay. So this is adjacent side. We know opposite side. We know the adjacent side to the angle. So tangent theta equals, so opposite side, right? Opposite side over adjacent side. So opposite side is 2,450, and adjacent side is 1,000 meters. So it's equals 2.45. So we use inverse of a tangent. Theta equals inverse a tangent 2.45. So I use calculator. Theta equals 68 degrees. So the well should be located, right? Should be drilled at an angle of 48 degrees. So it's 68 degrees. It's 68 degrees. So we use tangent to determine these angles. Okay, let's look at the second questions. Aisha is a forester. She uses a clinometer, a device to use to measure angles elevation to sight the top of the tree. She measures the angle of 48 degrees. She is standing 7.2 meters from the tree, and her eye are 1.6 above ground. How tall is the tree? The question asks us to find out how tall the tree is. This is 48 degrees, and angle of elevation, this is a right triangle. So I draw a diagram here. So it's 48 degrees, and this opposite side is height, and related to the 48 degrees. This adjacent side to 48 degrees. So this opposite side, adjacent side, we know the angles. So we can use tangent theta, right? So let's write that. So tangent theta equals opposite side, right? Opposite side or adjacent side. Okay, so opposite side we don't know, right? So tangent theta equals h divided by 7.2. So both sides multiply by 7.2. So the tangent theta is tangent 48 times 7.2 equals h. Okay. We use a calculator, get tangent 48 equals 1.11 times 7.2 equals h. So h equals around 8 meters. Okay. So the 8 meter is this side, high side, right? So it's a question asked, how tall is the tree? So we should add height to 1.6, right? So the tree height, so the height of a tree should be the tree height equals 1.6 meters plus 8 meters, 9.6 meters. So the tree is about 9.6 meters. Okay, let's look at the third questions. A group of students on an outdoor education trip, they leave their campsite and travel 240 meters before reaching the first orienteering checkpoint. They turn, creating 42 angle with their previous path, and travel another 100 meters to get to the second checkpoint. They turn again and travel the shortest possible path back to their campsite. What area of the woods did their triangular route covers? So I draw a diagram here. So this is a campsite, and then they travel 240 meters to the first checkpoint. So this side length is 240 meters, and then turn, create 42 degrees, and then go to the second checkpoint. This side is 180 meters, and then they turn again back to their campsite. So this is a triangle, right? So the question asks us to find what area the woods did the triangular route covers. So in order to calculate the area of this triangle, we know the base, 240 meters. We have to find out the height, right? So I draw a line segment perpendicular to the base. This is set to h. So we have to find out the h, right? So it's we know the 42 degrees. H is opposite side to 40 degrees. This is right angles, the right triangle. This is hypotenuse. So we can use it's opposite over hypotenuse. It should be sine ratios. So okay, so let's do it. And okay, so the first, and we use the sine. Okay, sine 42 degrees equals, and h over 180, right? So it's this is opposite side, this hypotenuse, and both side is 100 meter. Yeah, both side multiply 180. So 180 times sine 42 degrees equals h. So sine 42 equals 0.67. So 180 times 0.67 h. Yeah, equals h. So h equals 120.4 meters. Okay, we know the h. So this h is 120.4 meters. Okay, so the area A equals 1/2 times b base times h. 1/2 times b is 240 meter, right? Times 120.4, so equals 14448 meter square. So this is the area we want to find out. The area of the woods and that triangular route covered was about 14,448 meters squared. Yeah. Okay, let's look at the last questions. Lila stood on land 200 meters away from one of the tower of the bridge. This bridge is tower. He reasoned that he could calculate the height of the tower by measuring the angle to the top of the tower and the angle to its base at water level. He measured the angle of elevation to its top as 37 degrees and the angle of depression to its base as 21 degrees. Calculate the height of the tower from its base at water level to the nearest meters. I draw a diagram here, model the situation. So see, this is the tower, this is the roadway, actually the bridge, So this is 37 degrees. That's the angle of elevation from here, right? So this is the land. This is the roadway. This is 37 degrees. So this is 21 degrees. That's the angle of depression. So between this line, this side, and this line. So it's 21 degrees. This side is 200 meters, right? So we determine the height of the bridge, the tower, sorry, the tower from the base at water level to the top. Okay, so I create two triangle. So it's to a right triangle. So this is right triangle. This is right triangle. So for 37 degrees to 7 degrees. So this is adjacent side. Also is adjacent side to 21 degrees. So this is opposite side A, right? A is opposite side to 37 degrees. This opposite side is B to 21 degrees. So in order to determine the A, we can use tangent, right, ratio, because tangent 7 equals A over this side, adjacent side 200 meter, we can determine A. And we use tangent 21 equals B, so opposite side, and over adjacent side we know, so we can determine A and B, and then calculate the whole height and A plus B. Okay, let's get started. And so we know tangent 37, so tangent 37 degrees equals A over 200, right? It's A, right? It's the opposite side. 200 is adjacent side. So both sides multiply by 200. So 200 times tangent 37 degrees equals A. 200 times tangent 37 equals 0.75. So A equals and 150.7. 150.7 is A, right? So the B tangent 21 degrees, right, equals B over 200. Both sides multiply by 200, so 200 times tangent 21 degrees equals B. 200 times 21 degrees tangent 21 degrees equals 0.38 equals B. So B equals 76.8. B equals B, right? So the height, our height, right, equals A plus B equals 100.7 plus 76.8 equals 227.5. Okay, so this is the tower. Yeah, the tower about 228 meters. It's from its base. Yeah, from its base. This is a base, right, at water level to the top. So its total is 220 meters around. Okay, let's look at the summary. And if a problem involves calculating a side length or angle measure, try to represent problem with models that include the right triangle. If possible, solve the right triangle using primary trigonometric ratios. To calculate the area of a triangle, use the sine ratio to determine the height. For example, suppose you know AB here, you know AB, and angle C in the triangle at the right here, right? To calculate the height, yeah, we can use sine C, right? Sine C ratio equals opposite side length H over hypotenuse A. So if we know A, so we can determine H equals A multiplied sine C. So area of a triangle should 1 over 2, and this base, and multiply the height. Height is equals A sine C, right? So yeah, this we use the trigonometric ratio to determine the height, and then continue to determine area. Okay, so here is a lot of practice question here. This first question, second question, answer at end, and third, fourth, and 5, 6, 7, so 8, 9, 10. Sorry about that, guys. 11, 12, 13, 14, and 15, and 16, 17, 18, 19, 20. A lot of questions. I know the practice makes perfect. This is the answer. So if you're interested, you want to do the practice, yeah, you can do it and check the answer here. Okay, that's it. Thank you for watching.